tragedy on the racetrack led to the development of the head and neck restraint in the 1980s. Investigations had revealed a deadly trend in motorsports. With the driver's body restrained, the head moved violently in a crash, causing fracture to the base of the skull. Clearly, more restraint was needed. Attached to a helmet, a head and neck restraint is designed to save the racer's skull. It has become required equipment in many racing organizations. To make these restraints, they mix plastic and carbon fiber pellets. The carbon fiber fortifies the plastic, which is made of castor bean oil instead of petroleum products. A machine melts the mixture and injects it into a mold under pressure to produce the base structure for the restraint. The operator breaks off what's known as the sprue, plastic that's solidified in the channels leading to the mold. He trims the plastic and carbon fiber overflow from around the edges. This overflow is known in the industry as flash. He hangs the parts to cure over a 24-hour period. The next day, the employee clamps the part in a jig and activates computerized tools. The first one drills holes for tethering the restraint to the helmet. Another trims it to its final size. An automated hot knife now cuts nylon tether material to the correct length. Then it's over to a computerized sewing machine to stitch the tether around a chrome fitting. The stitching pattern has been designed by an engineer to withstand the force of impact. The operator then stitches on a label, which says the tether's design has been sanctioned by both American and European racing organizations. Next, using a die powered by bursts of air, a worker punches out shoulder pads from cushiony foam. The next member of the team slides the shoulder pads into casings made of fire-resistant cotton. It's a snug fit, and without a special installation tool, the job wouldn't go smoothly. By folding the pad into the tool and then inserting it into the long case, there are no bunch-ups. Some head and neck restraints are adjustable, so drivers can find a more comfortable fit. They assemble those restraints in 3 pieces with the adjustable fittings in the joints. The employee then paints adhesive primer onto the base structure of the head and neck restraint. He coats most of the plastic and carbon fiber surface with it. He applies neoprene padding to the primed surface. The padding is adhesive backed and it bonds instantly. He attaches the tether to the back of the restraint with plastic clips and screws. Using hook and loop tape, he secures the shoulder pads to the underside of the restraint's yoke. Another worker applies more certification labels. They signify that the actual structure of the head and neck restraint meets standards. They now test a randomly selected restraint. A hydraulic arm pulls the tethers until the restraint snaps, mimicking the force of a violent impact. The restraint withstands more than what's required and breaks in the right place. Next, an employee attaches a head and neck restraint to the helmet using the tethers. 2 crash dummies put the restraints to the test. The one on the left isn't wearing a restraint, while the right one is. Steady nerves and a steady head could save a racer's life, and a head and neck restraint definitely improves the odds.